All right, today we're going to be looking at intro to limits. Um, Limits are usually based off of a function where they have certain qualities. So in this case, we have x squared over 2, where x cannot equal 4. However, 3, when it is 3, x equals 4. So what this will look like on the graph is something like this. We'll go by increments of 4 on the x-axis, and then we'll go up to 8 right here. Go 4, and then 8. Now, right here we would have, let's see, one right here, right here. You draw the parabola. More or less, this is what the parabola would look like, although it would look a lot more symmetrical. So so 3 would be somewhere right here. We'll call this 3. 3, x is x is equal to 4. So, oh, this is not negative 4 right here. There we go. Um, right here, x would be equal to 4. So, let's see here, 4 would typically be right here. But, oh, what's going on? All right. Okay. Since x cannot equal 4 in this function, there'd be nothing right here. Let's actually fix that to make it look more obvious. There we go. So nothing is there. However, at 3, it would be right here. So this is actually right here. So the limit would be at x cannot equal 4. So where it would usually be on this parabola, it is not there. But in turn, it is right here. So basically, nothing can be right here if it is pointed out in this equation. We could go ahead and add another one, so we could say like x cannot equal, um, let's say -2. So at -2, right here somewhere, at -2, it would be, we'll just call this 1. And then if we go down here, we could assign it any value. So it cannot equal there. So we'll say at, well, let's go actually here. Let's at, we'll say 8. At 8, x equals, let's fix that right there. X equals -2. So at 8, x equals -2. So this is basically inserting its own rules. So right here, the rule is that x cannot equal 4, x cannot equal -2. Right here, when it is 3, x equals 4. X, when it is 3, x equals 4. And x cannot equal 4, hence right here. Right here, x cannot equal -2, right here. When it is 8, x is equal to -2, right here. So these limits are represented by an open circle on the graph, and basically are a visual marker as to where these numbers do not exist. They could get close to it, so we could get, let's say, we'll go right here, x equals -4. So when it gets to this spot right here, it could get infinitely close to it, but it cannot exist on this number 8, on this plane here. So x equals 8 for this right here, it won't exist. This will never exist. Instead, it would be right here. So it could get infinitely close to it, but it cannot ever reach it. This has been Intro to Limits with Nevin Aguilar.